This is our Voltaic cell battery, which we will be explaining in terms of electrochemistry, which is the study of relations between electricity and chemistry.
In our battery, there are many different components. These components include an anode, which is the element that is oxidized, being the tin, and the cathode, which is reduced, in the lead. Both of these elements are placed in ionic compounds, including tin chloride and lead 2 nitrate. Our salt bridge is composed of filter paper dipped in potassium chloride. We also have 2 alligator clips, a voltage meter, which calculates the voltage of a battery.
To determine which metal is the anode or the cathode, you must use the activity series. Since tin is higher on the activity series, it is the anode, and lead is the cathode. As the reaction occurs, tin becomes oxidized and lead becomes reduced.
Electrons play a major role in the course of a battery, and they are constantly moving. Tin electrons travel through the alligator clips to the lead, creating an electric current. Both electrodes undergo half reactions. These half reactions can be seen below. The tin becomes oxidized and the lead becomes reduced, and the electric current is measured through the voltage probe.
Electrolytes play a very important part in our battery. To balance the positively charged tin electrode, positively charged tin ions move from the tin electrode to the aqueous tin chloride, giving the appearance of corrosion. To balance the negatively charged lead electrode, positively charged lead ions move from the aqueous lead 2 nitrate to the lead electrode, giving the appearance of adhesion. Because the tin chloride and the lead 2 nitrate have charges, they are considered electrolytes. Spectator ions exist as a reactant and a product in an equation, in this case chlorine and nitrate.
The salt bridge is one of the most important parts of the battery. It is used to balance both of the ionic compounds. As electrons leave the tin metal and through the alligator clips, positively charged tin ions move off the anode and into the tin chloride, giving the solution a positive charge. Negatively charged chlorine ions move from the salt bridge to the solution, giving it a neutral charge.
As electrons move into the lead electrode, positively charged lead ions move from the lead 2 nitrate to the lead electrode, giving the aqueous solution a negative charge. Positively charged potassium ions move from the salt bridge to the solution, giving it a neutral charge. Giving the solutions a neutral charge allows the reactions to keep occurring.
To predict the voltage in batteries, we can use resources from our textbook. In the standard reduction potentials list, you can determine the predicted voltage by subtracting the higher element from the lower one on the list. The predicted voltage for our battery for tin and lead is 0.26 volts. The equation to find this can be seen below.
It is important for batteries to be able to resist corrosion so they can last longer. The most common corrosion method is to apply a protective coating. Protective coating are corrosion resistant and are designed to separate the surfaces that are susceptible to corrosion. As you can see below, these drill bits are covered with a protective coating.
Rechargeable batteries. Rechargeable batteries work the same way as non-rechargeable batteries, except after all the energy is used up, the reaction is reversed. Electrons move from the cathode to the anode by way of a charger, allowing the energy of the battery to be built back up, thus recharged.